All right, fingers crossed I can get this to work now. So this should be the Excel file. It's just a PDF version. It took a minute to get it to work in VB Collaborate. But here's the general idea. So what you're going to see, that units of labor, right? It's a just slightly different production function than what we had before. Again, going up to 10. Let's see if I can zoom in at all. All right, that's better. All right, so here we go. So there's the units of labor, the total output, that marginal product of labor like we just discussed. It's the change in output divided by the change in labor. One of the ones we did not talk about was the average product of labor. So average product of labor is going to be your output divided by your workers. So if one worker produces 10, that's an average of 10. If 2 workers produce 24, that's an average of 12. If 3 produce 36, it's an average of 12, and so forth. Okay, so there's the production stuff that we just did in that previous video. Fingers crossed that it's all part of actually the same video. I don't know what I'm doing anymore. All right, so fixed cost, those, remember from a previous lesson, are the costs that don't change with output. So in this particular example, my fixed cost equal 50. Whether I'm producing none at all, or if I am producing 67.5 units, right? My fixed cost, like my rent, for example, is still 50. My variable costs, so variable costs are costs that change. In this particular problem, my variable costs are $10 per worker. All right, so if I have 1 worker, then my variable cost is $10. If I have 5 workers at $10 each, my variable cost is 50. All right, so variable cost in this case, right, is the number of workers times the wages they earn. And then my total cost is the sum of fixed and variable. We've seen that before. Just add those up. So there's the basics of my costs and my production, but now we've got some new pieces to add. Okay, so the first one is that phrase marginal cost. All right, remember marginal, I said in the few minutes ago, hopefully it's on the same recording. Marginal means change. All right, marginal means change. So marginal costs are going to be the change in costs divided by the change in quantity. I wonder if it'll let me write on this while I'm sharing a screen. Oh, it will. That's really weird looking, but it'll work. So it's the change in costs divided by the change in quantity. So in this case, that's a Q, you just can't tell. All right, so going from, say, 0 workers to 1 workers, my costs increase by 10. My production goes up by 10. So 10 divided by 10 is 1. In the next case, my costs go up by 10, but my production goes up by 14. 10 divided by 14 is that 0.714 figure. Another way to think about this marginal cost, if you think about change in cost and change in output, and the fact that change in output is essentially your marginal product of labor, since that change in labor is always 1 unit, is you could approach marginal cost several different ways. All right, so let's see if I can type this all out. Making my font really big now because I'm zoomed in here, but okay. All right, so basically the idea is that, so it's the change in cost divided by the change in output. Those change in costs, remember that fixed costs don't change. So those change in costs are really the same as change in variable costs. That's important to note. And then as well, that change in quantity, if you've only got labor changing by 1 worker at a time, that change in quantity is basically the same as your marginal product of labor. So what we've really got here is the change in our variable cost divided by that marginal product of labor. All right, so if I were to think about this as an equation, let's see if I can get my writing tool back. So if I think about this as an equation, right, so it's the change in those costs divided by that marginal product of labor. That if you remember the way that that fractions work, right? As the marginal product of labor gets bigger, then this fraction overall would get smaller. And as the marginal product of labor gets smaller, then this fraction would get bigger, right? So in other words, there's an inverse relationship between marginal cost and marginal product of labor. So that when marginal product of labor is going up, when marginal product of labor is going up between the 10 and the 14, my marginal cost is going down, see, from the 1 to the 0.71. And then when the marginal product of labor is going down, my marginal cost is going up. So there's an inverse relationship between marginal cost and marginal product of labor. Those two are going to look like reflections of one another. We'll see the graphs in a minute here when I finish. All right, so those two are going to look like reflections. If marginal product is going up, you know that marginal cost is going down. And if marginal cost is going down, you know that marginal product has to be going up. So a couple other curves that I want to hit on. Average fixed cost. So remember, well, average fixed cost equals fixed cost over quantity. Fixed costs are constant, right? So this part of the fraction is constant, the fixed cost. So as the Q gets bigger, it makes sense that those fixed costs would get smaller and smaller. So what you're going to see here in this column is that your fixed costs are going to get smaller and smaller and smaller as output gets bigger. It will never reach zero, but it approaches zero. Again, we'll see what those look like on a graph. Average variable cost over quantity. This is actually going to be a reflection of your average product of labor. Again, you could think about why that is. It's the way that these equations are essentially set up. Is remember that variable cost equals wages times the number of workers you have, right? So wages times the number of workers you have divided by quantity, right? So that's that formula again, just written differently. And if you think about average product of labor was the amount of output you have, which is quantity, divided by the number of workers, which is L. So again, in one hand, you've got L over Q, and on the other hand, you've got Q over L. So those two are also going to be inversely related. All right, so if average product is falling, average variable goes up. If average variable, sorry, I just said it wrong. If average product is falling, average variable is going up. If average product is going up, average variable is falling. So you should see that relationship again here, right? You've got the 10 to the 12, and then as the 10 rises to 12, you see your average variable falls from 1 to 0.833. And then once your average product starts to fall, then your average variable is rising. Okay, so that's another important relationship that you might want to be aware of between these. So now what do all these things look like on graphs? Oh, last column here, just cut off because I had to save it as a PDF. I couldn't share the Excel file the way I wanted here. Average total cost, actually I do want to make mention of this. So average total cost equals average fixed cost plus average variable cost. Okay, or conversely, it's your total cost over your quantity. So with average total cost, average fixed is always falling, right? This part is always going down. This average variable starts off going down and at some point picks back up. So in the beginning, right? So if we're thinking about in the beginning here, average fixed is falling, average variable is falling, therefore average total is falling, right? At some point, average fixed is falling, average variable starts to tick back up. All right, and so it's possible for this to continue going down, but at some point it's going to tick back up. And especially as these changes in average fixed get really small, the average variable is going to be picking up faster and faster.
such that the average total is also going to take a U-like shape. But you're going to see on the graphs here in a second that the minimums don't line up. So the minimum of the average variable cost is not going to line up with the average total cost. The last thing I want to mention that we're going to see here in a second is that I just blanked out here. The relationship between average and marginal. Okay, so what I want to say is the relationship between average and marginal, oops, let's not type this in a yellow font. That is not a good idea. Hold on. Averages move in the direction of the marginal changes. Right? So for example, if the marginal is above the average rises. And I'll explain this in a second. If the marginal is below the average is falling. So what does that mean? Let's just take an average that you guys are all familiar with, right? Your GPA. Let's say you've got a solid GPA of a 3.0, right? And maybe you guys are, finishing up your sophomore year, starting your junior year, right? So you've got that 3.0 for, let's say, 45, 60 hours, whatever it is you've completed so far. If your GPA this summer is a 4.0, you make A's in your classes this summer, then the change, right, those additional classes that you took have a GPA that is higher, right? I can say it like that, yeah. So your summer semester GPA is higher than your overall GPA, so your GPA is expected to rise, right? If your grades this summer are higher than what you were making, your GPA rises. If, however, your grades this summer are like, let's say, all C's, and you make a 2.0 for the summer, if your summer grades are below your GPA, then you can expect your GPA to fall. All right, so the marginal pulls the average with it. If the marginal is rising, if the marginal is above the average is rising. If the marginal is below the average is falling. So now I want to show you these graphs, okay? So these are the graphs. The first one's marginal product. The second is the cost curves. It looks like my cost curve got cut off. Thank you very much, conversion to PDF. I'll see how to work this. So here's my marginal product, right? You see it rising, and then you see it falling, right? In the example I gave in the first part of this video, it even goes negative. This one does not, but there's no reason it could. Here's my second graph, and I'm going to be switching back and forth. This is going to be really hard. This green line here, okay, I'll just go with this. I'll show you on this one. So this green line here, if you come back to the first part of the graph, the green line is falling, 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 falling. Go to the bottom of the graph here. It is still falling, 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 falling. If you look at the Excel files that are in the content section, you will not have a page break in the middle of your graph. So that green line is constantly falling. That is my average fixed cost. All right. The one that looks like the check mark, right, that has the biggest drop to begin with and then the biggest increase. So we're looking at that red line here, this red line. Okay, so it's got the fastest drop to begin with, and then it goes up. It looks like a check line. That is my marginal cost. That's the one that's the reflection of this marginal product of labor. And I'll switch to draw this out for you again in a second so you guys can see. Actually, I don't need to, because I believe I've got attached copies of notes already with all these graphs drawn and lined up. And then now we've got our, let's see, we've done fixed, we've done variable, we've done, fixed and marginal. And where is the other curve here? Let's see. Okay, so now this purple one is going to be my average variable. Okay, the purple is the average variable, and then coming on to the next graph, the blue is the average total. Okay, so the average total always has to be on top of the average fixed and average variable. Why? Because the average total equals the average fixed plus the average variable. So average total is always the one on top,
and then the average variable is more of the U-shaped one that's on the bottom. Last thing to notice is that the marginal cost curve is going to intersect, let's see if I can do this here. The marginal cost curve is going to intersect average variable at the minimum of average variable, and that marginal cost curve is going to intersect average total at the minimum of the average total. So it's a lot of calculus as to why that is. I don't want to get into that, but the marginal curves, marginal cost, is going to intersect average variable and average total each at their minimum points. All right, so that's this lesson. Again, you guys actually have a lot of the information that you needed. I hope this video recorded my 2 parts when I paused in the middle. There are handwritten notes with the graphs. There are typed up notes already in the content. Hopefully none of this comes as a surprise. As always, if you guys have any questions, please reach out to me. I know this material is hard, and it's even harder probably in this asynchronous format. So with that being said, your test 2, I will extend the deadline on that. It's got 3 parts. It's got the market efficiency, it's got the elasticity, and it's got the cost curves, production, business decision stuff. Each part or each kind of topic is worth 1/3 of the test. So good luck, and let me know if you got any questions. Take care, guys.